This is a brief introduction to human body model positioning using the Oasys LS-DYNA environment. Pre-simulation is fast becoming the norm for positioning dummies in your LS-DYNA models. This method prevents initial penetrations and means you can couple together positioning and seat squash, utilizing all the realistic material properties and contacts available within your models. Here, we have two examples of positioning analysis. The first one is a one-stage analysis. This means we have just created one set of cables to pull the dummy into position. You can see here that the dummy is moved into the seat, squashing the seat foam, at the same time the arms and legs are moved into position. On the right, we have a two-stage positioning analysis. Here we have two sets of cables in series. The dummy starts above the seat, and the first stage is to move the arms and legs into position. The second stage is to move the whole dummy down into the seat. Dummy positioning involves using a dummy tree, and these are post-star-end keywords that contain information on assemblies of parts within the dummy and how they are connected together. These trees allow you to move the dummy around easily in Primer. All the traditional dummy models on the market, from Humanetics, WorldSyd, LST, etc., come with a dummy tree created by the manufacturer. Now we have produced dummy trees for various human body models that allow you to set up pre-simulation positioning analysis within Oasys Primer. So the process is thus. You read your dummy model into Primer along with the dummy tree. You then use Primer to specify your target position. Once the dummy is in the desired position, Primer will automatically calculate cables required to pull the dummy into that position in an LS-DYNA simulation. LS-DYNA will write a DYNA-IN output file at the end of the analysis. The DYNA-IN file contains the updated nodal coordinates and initial stresses of the final position. These can be imported back into Primer. We have now created human body model trees for the leading human body models on the market. Let's look at how easy it is to specify your target position within Oasys Primer. So here we're looking at the skeleton of the GHBMC model, so you can visualize what's going on internally when using the positioning tools. The human body model trees define child-parent assemblies and joint definitions based on anthropometric data. This allows assemblies to be realistically articulated in tandem. You can see in this model, we have defined many assemblies in the spine, so you can easily do things like move the head back and forth or straighten the spine. Everything is connected in a realistic way. So you can see in this example, when we're moving the arms, the shoulder joints and clavicle also move realistically. You can also see that realistic stop angles have been added to ensure appropriate relative movement between the various assemblies. So here we have an example of a simulation positioning analysis that has been run in LS-DYNA. These are the output results of a model that has been set up in Primer using the process described. As you can see, the analysis has different stages. First, the whole human body model moves up. Then the hands move into position. And finally, the feet move into position. At the end of the analysis, the updated nodal coordinates can be inputted back into Primer to achieve a penetration-free positioned model. So, Primer human body model positioning trees have been developed for all the detailed GHBMC models, and that includes pedestrian and occupant. And we've also produced positioning trees for the following thumbs models, and we're continuing to produce more positioning trees for thumbs models as well. The trees are freely available to Oasys users. Many of our customers are now successfully using them, improving their workflows, and achieving higher quality LS-DYNA models as a result. So if you want to give them a try, please do get in touch.